In this problem, we have 80 grams of copper reacting with excess sulfur. That means the sulfur doesn't matter, to produce copper 1 sulfide. So first thing to do is to make sure the equation is balanced. And you can see it's not, and this is actually a very easy one to balance for most people. You have 2 copper here, but only 1. So if you put a 2 right there, now it's balanced. Let's write down our conversion factors so we have them all ready. We know that to get from grams of copper to moles of copper, we're going to have to use 1 mole of copper equals the molar mass. If we look at the periodic table, the molar mass is 63.54 grams of copper. We also know that if we want to get from the copper 1 sulfide from moles to grams, we have to use its molar mass as well. So 1 mole of Cu2S equals, and we already have what 1 copper is, and sulfur is 32.06. So the molar mass is 159.14. And finally, we're going to need the mole ratio to convert between moles of copper to moles of Cu2S. So we're going to look at our balance equation. So 2 moles of copper equals 1 mole of copper 1 sulfide. Now all we have to do is the dimensional analysis. 80.0 grams of copper, and see that I wrote the 0.0 so that when I go back and count significant figures, I get that correct. We're trying to cancel out grams of copper, so we're going to put the molar mass of copper on the bottom. The molar mass of copper equals 1 mole. So we start with 1.25905 moles of copper. Next step is to use this mole ratio in order to convert from moles of copper to moles of copper 1 sulfide. We're trying to cancel out moles of copper, so we have to put moles of copper on the bottom. And our balance equation tells us to use 2 moles of copper and 1 mole of Cu2S. So that means we will make 0.629525 moles of copper. So I'm going to say and the final step is to use copper 1 sulfide's molar mass in order to find the grams. So to cancel out mole, I have to put 1 mole on the bottom and its molar mass on top, which is 159.14. So mole cancels out. And we multiply. And you get 100.183. Let's talk about significant figures. We have 3, 4, and 5, so we need to round our answer to have 3. Now, let me write what the calculator said, because this one's a little tricky. So 3 would be right here, but we need those zeros to be significant. So we have 2 options. You can write it like this, but make sure you put a decimal, or you can write 1.00 times 10 to the second grams. I'll accept either of those answers in terms of sig figs.